Hey everyone, welcome to a very special repair video. A few weeks ago, Steve from TronicsFix attempted to fix a PlayStation 4 motherboard and unfortunately couldn't fix it because he found that one of the RAM ICs was faulty on the board. Fortunately, he sent that board to me and I have that board right here. I've had this board for a couple of days now and I've been very tempted to open it, but I thought I'd open it on video and bring you all along on the journey. I just want to give a massive shout out to Steve from TronicsFix and say a big thank you for giving me this opportunity. Hopefully, fingers crossed, we can get it working. Let's get this open and let's see what we can do with it, shall we? Alright, so the first thing that I'm going to need to do is, of course, get this thing open. So let's do that now. So I've been itching to get into this for quite a while now, to be honest, and yeah, I just haven't got round to getting to the point where I can actually take a look at this. So this has come all the way from the United States. Obviously we live in the United Kingdom, but this has come all the way from the United States, and once again I want to thank Steve for giving me this opportunity. Just to recap then, while I'm unpackaging this, basically this motherboard Steve attempted to repair on a video along with several others, and I'll link into that video down below. And unfortunately this one, he found that there was a short on the RAM, so he offered to send it to a small YouTuber, and several people recommended me, and I'd like to thank everyone who did recommend me, because this has given me a great opportunity to not only show that, you know, sometimes something that one technician can't do, another technician can, but also the fact that this is going to help me to build a relationship with other YouTubers, and I really appreciate that. And you know, it's given me an opportunity to learn and also to grow at the same time, so it's quite exciting, really. Very well packaged, I must admit. Hopefully it survived the trip. Alright, here we go. Ooh. Okay, right, so let's just get this packaging out of the way, and I'll show you one thing that I'm noticing straight away, actually. So I'll just chuck that to one side because I'm a messy technician. And one thing I'm noticing straight away is that there's a burn mark on this. So this might be really interesting to see what's actually going on. So you can see just here, there's a burn mark there. So right away, that's one thing I'm noticing. So I'm assuming now, it's been a while since I've watched the video. It's been about 4 weeks, I think. So it's been quite a while. I'm assuming, oh yeah, it's that one there. Ah, okay, yeah. Right, okay, so this is the RAM IC that Steve has removed. Okay. So that's why he taped that to there. Alright. Well, that saves me a little bit of time, I guess. So, yeah. So basically, let me just explain what I need to do. So the first thing I'm going to need to do is I'm going to need to get a donor board. And if you don't know what a donor board is, it's essentially a board that is basically dead. And I'm going to need to take another RAM chip off the donor board. So one of the RAM chips off the donor board I need to take off. I need to replace the solder balls underneath. So if we take a look at that chip there, we can see that we've got quite a few solder balls. I believe there's 180 balls on these particular ICs, and they are 0.45mm in size. So we basically replace the solder balls that are on there, and by doing that we can basically reuse that chip. Now the reason that Steve wasn't able to do this, or sorry, I'll rephrase that, didn't want to do this, was because it can be quite a time consuming process, and you might not end up with a working board at the end of it. So what could happen potentially is I could reball this IC or reball another IC, install that IC onto this board, and then it could have another fault. And then it gets to a point of where it's probably not worth fixing for a normal technician. Now I'm just fixing this for the sake of fixing it, so I will go above and beyond to get this working. I accept that challenge, and I'm going to go above and beyond to get this working. So I believe that this had a long pulsing blue light of death, and I do have several videos on the channel where in the past I've had a long pulsing blue light of death, and it turns out to be a faulty RAM IC. The reason that these RAM ICs go bad is pretty unknown. This one has obviously had some sort of a very big short on it, as indicated by the very visible burn marks on both sides of the board. So the burn marks that are here and the burn mark that is here, that is not going to be down to the removal of the chip. And the reason I know that is because it's travelled through to the other side. So this has got very, very hot in a short period of time. And that's one way that we generally know when we've got a short on the RAM. Obviously I can't test this until I reinstall that RAM. So I'm going to get a donor board, I'll remove a RAM IC off there, reball it, prepare this board, get it ready, and then we'll get it installed. Right, so here I have a beautiful looking donor board. This is an SAD002 model, so this is the PS4 Slim. But as you can see, I've got quite a few RAM ICs here to pick from. And what I'm going to do is I'm just going to take one or two off. I might take the two off just in case I mess the first one up. And basically I'll get the RAM ICs reballed, get it ready to install onto here, and then I'll start preparing this board. So the first thing I'm going to need to do then is I'm going to need to remove one of these chips. So I'm going to set up the microscope. We'll take a look under the microscope. I'll walk through how I'm going to remove the IC, and then I'll walk through how I'm going to reball it as well. The first thing that we're going to need to do with this is add a little bit of flux. And flux is going to help the solder to flow. So basically we want to help the solder to flow so as it doesn't basically get stuck, and the solder flows evenly and allows us to remove it without damaging the traces on the IC itself. It doesn't matter if we damage the traces on the board for this particular board, and the reason for that is because, like I said, this is a donor board, so this board is never going to work again. This has had so many things removed off it that it's got no chance. And we just add a nice bead of flux all the way around, and then I'm going to take my hot air station. So the hot air station that I use is an Atten ST862D. I'm going to set the hot air to 440 degrees Celsius. I'm going to set my airflow to 20%, and I'm going to get this removed. So I'm going to start coming in from quite a distance, and it's going to be around about 4 inches away from the IC itself, just to get some heat in the general area and get this chip removed as safely as possible. We can of course use the BGA rework station, but I do understand that a lot of people are not going to have a BGA rework station, which is why I'm not using it for this particular repair, because it's not an easy repair, but it's also not a cheap repair when you factor in the fact that you've got to have a BGA rework station. So I'm doing it with hot air just to prove it can be done using normal hot air. So what I want to do is I want to put some heat in this board and try and distribute the heat as evenly as I possibly can. And the reason for that is because this is a RAM IC and they are sensitive to heat. So I don't want to overheat it too quickly because I don't want to damage it. This is going to be going onto the board that I'm working on. Okay, and that chip has moved, so I'm going to give it another few seconds. And then just lift the IC off the board. So there is one IC removed and ready for reballing. But while there's still some heat in the board, I'm going to remove another IC just in case I mess the first one up. So I'm going to do the same again with this one. Okay, and you can see that chip moving. So let's just lift the chip off. And done. So with that out of the way, I can now move this donor board. We don't need that anymore, so I can get rid of that. And as you can see here, I now have two hopefully good ICs which I can reball and pop one of them onto the PS4 board that we're working on. Right, so what I need to do next is I need to prepare this motherboard for the new chip, because we're not going to be able to install a new chip as it stands right now. So what I'm going to do is I'm going to replace the solder that's on here at the moment. So this solder that's here, I'm going to replace with leaded solder, and that's going to lower the melting temperature to melt that solder, and then I'm going to wick it away using solder braid. So here's the motherboard that Steve sent over. First thing I want to do is just apply some flux while my soldering iron is preheating. So there's some flux still on there from when Steve removed the chip, but that's not a problem. I can clean that off afterwards. And then take some leaded solder, get a nice ball of it on the tip of the iron, and then just go around in a nice circle. So the next step is going to be to take a little bit of solder braid, run the soldering iron across, and just clean up all of this solder, and you'll see this solder will suck up onto the wick and clean off the pads for us. And we may have a torn trace. Let's make sure those pads are nice and clean. The next thing I need to do is just give the board a nice clean. So I'm going to get some heat in the board, because when the flux goes dry it basically hardens, and by putting a bit of heat into it, it's going to allow me to clean off the board a lot easier. So I'll just use a bit of hot air and just put some heat in the general area. And then I'm going to use some isopropyl alcohol and a cotton swab. I'm just going to keep on cleaning until all of the burnt flux is gone and we have a nice working area to replace the chip. So let's zoom in now and let's inspect the area. And I believe we just have the one torn trace. However, if we take a look at that particular trace, that trace always comes off. And the reason for that is because it's not connected anywhere. So we can see here that we've got this trace here, for example, and that goes to this point here. So that goes to what's called a via or a via. And a via is essentially a pathway to another layer on the board. In this case, it's probably going all the way through to the other side of the board. And you can clearly see that this is connected here, but this one just here, there's no via. And the reason for that is because it's a not connected pin or a not connected pad. So we don't actually need that pad to be present in order to get this working. So with that done, you can see that this board is pretty much prepared and ready to go now. So all we need to do is get this chip reballed, and then we can pop a new chip onto here, and hopefully, fingers crossed, we're going to get it working. So the next thing I need to do is I need to do pretty much the same as what I did with the board, but on the chip. I need to prepare the chip so as it's ready to accept new solder balls and then ready to be installed onto the motherboard. So I need to replace the solder that's on the chip with leaded solder. That's again going to reduce the melting temperature. And then I need to wick all of that solder away, clean off the chip nice and flat, and then we can do a reball, get all the balls replaced, and fingers crossed we can get it working. So this device here is called a reballing jig, and what this does is it allows me to secure the chip in one fixed position to be able to reball it successfully without the chip moving around. Because we don't want the chip to move around, we need every single solder ball to be perfectly aligned and in the correct position. We don't want two balls on one pad, we don't want a missing ball, and we don't want any balls to be out of alignment as well, because it's not going to adhere to the motherboard in the correct location. So we install the chip into a reballing jig, and that's going to allow us to reball it successfully, or hopefully reball it successfully. Let's just move that one out of the way, that's sticking around. But it's going to allow us to reball this successfully and basically get the chip ready to be installed onto the board. So I'll just grab that back out of there. It's a little bit the wrong size. So what we need to do is just adjust the size of the jig to the right size for the chip. So let's just lock that into position. There we go. And now, as you can see, that's nice and solid, so that's not going nowhere. So that chip isn't going anywhere now, which means I can reball this properly without having to worry about it moving around. So, like I said, what I'm going to do is I'm going to add some flux to the IC. And then I'm going to replace the solder that's on there again with some more fresh leaded solder. Once again, I'm not going to put any pressure on the chip. I don't want to damage the pads. So I'm going to add a ball of solder onto the tip of the iron. And then just go around in a circular motion. Very, very lightly. Same for this side. There we go. Let's clean off the tip of the iron. Let's get a fresh piece of wick, so just cut a little bit of that away. And then just wick away at the chip itself. Awesome. So that should be nice and clean underneath all of the burnt flux. Let's just give that a clean with some isopropyl alcohol once again. So a little bit of isopropyl alcohol and a cotton swab. Should be all we need. Just make sure that's nice and clean. Then I want to inspect it under the microscope and make sure that we don't have any kind of bumps or anything that's going to cause us a problem when we're trying to reball the chip. And as you can see, that looks pretty spot on. Perfect. So that should be absolutely fine for reballing. Alright, so the next thing we need to do is we need to put some new solder balls on this chip. Now, I don't currently own a stencil for the PlayStation 4 RAM because the PlayStation 4 RAM is different to normal RAM. I do have a stencil for normal RAM which has only got 3 rows, but this one has got 5. There's 180 balls in total and they are 0.45mm solder balls, which is why we have to do this underneath a microscope because they are just far too small to do it by eye. So the first thing that I'm going to do is I'm going to add a layer of flux. I really don't need much here, just a nice even coating. So just wipe it across with my finger. And that is still too much. So I'm going to wipe a bit more away. And now you can see we've got a nice even coating there. And what that's for is to allow the solder balls to basically stick in place as I'm moving them with a pair of tweezers. So because I don't have a stencil, I need to do this by hand, and I've done this many times before. It is a lengthy process, but you can get fairly proficient at it and you can get it pretty accurate as well. What I'm going to do now is just drop a bunch of solder balls out of the tub onto the chip. Doesn't matter if we've got too much, but we want to ideally get more than we need. And the reason for that is because once we get so far down, we're not going to be able to add any more balls onto the chip because they'll just fly everywhere and knock all the ones that we've already put in position out of the way. So we add more than we need and then just split them up evenly. And that's going to allow us to reball this chip by hand without the use of a stencil. And now what I'll do is just zoom in so as we can see it very closely and basically just start to position all of these balls onto the chip. So I will probably fast forward through a lot of this, but I just want to show you how we actually do it. So this is a very time consuming process. It does take a little bit of a while before you start to get into a nice rhythm. basically all we're doing is just positioning these balls by hand onto the solder pads, so as there's one ball on each pad. You might find that some of them won't quite sit on. That doesn't really matter too much. They can be out of line slightly. You just don't want them too far out of line, and the reason for that is because when we apply hot air to melt the solder balls, we don't want them to blow away. We don't want them to merge, and we don't want them to basically have one or two pads where there's no ball at all. So as closely to being lined up as possible. And you'll notice occasionally that the solder ball will probably stick to the tweezers or to whatever you're using. And if it does, don't worry, just wipe away the tweezers. These solder balls, you know, you can buy 12,500 of them for a couple of £1 on AliExpress. They're very, very cheap. When there's only 180 balls on each of these chips, you can do quite a lot with that 12,500. So don't worry if you waste a few. Okay, and as you can see, we are 50% of the way done. So that took around about 4 minutes for me, but I'm not sure how long it would take you. I think the first time I ever done this, it took me a lot longer than 4 minutes, probably more like 40 minutes to do a full chip. Now it takes me around about 10 to 15 minutes to do the full chip. So you do get used to it, for sure. You do get used to it. Okay, so sometimes you'll notice that some of the balls will bunch up, and the best thing to do there is just move them out of the way. You don't need as many balls as you've put on, so just push a few out of the way, push them off to the side, push them off into the middle, whichever you feel more comfortable with. I just generally just nudge them out of the way. We are around about 2/3 done. Right, so now I'm getting close to the end. I'm just going to start pushing a fair few solder balls out the way and completely off the chip. Reason for that is because I don't really want that many balls on the chip now. I know that I'm going to have more than enough, so I might as well just move some. One little thing I do need to say is if you've put them on the chip and there's flux nearby, or even if you took them out of the bottle that they came in, don't reuse them once you've moved them off the chip and started to move them away. And the reason for that is because they're going to be sticky. It's going to cause the rest of the balls inside the tub to go sticky, and you don't want that. You want the solder balls to be as clean as you possibly can get them. And one thing you'll notice is I've just messed up a little bit by knocking a couple of those balls out of the way, but not going to panic, just going to carry on, realign them. So that's one issue you face with putting too much balls on. Okay, that's one ball on every pad. So I'm going to give it a final clean up now. So what I'm going to do now is just going to move some of these solder balls out of the way very carefully, trying not to knock any of the balls that I've already placed on there. Whoops, just like that. So I'll just push the rest off to the side. We don't want any extra balls on the chip other than what need to be there, because the hot air will blow them towards other balls. If that means picking them up one by one, then that means picking them up one by one. Okay, so this looks fairly close to being lined up. So what I'm going to do now is apply some hot air and flow all of these solder balls onto the pads so as they're all stuck down, and then I'll use some flux, reflow them, and they should align perfectly with the pads on the chip. So for this process we want as low of an airflow as we possibly can. So what I use is 5% airflow and 420 degrees Celsius. The solder balls don't need that much heat to actually start to melt because it's a very, very small mass on the ball itself, so they melt quite quickly. So 420 degrees with 5% airflow, so that's a very, very low airflow, and the lower the better, really, because we don't want to blow anything out of the way. And I'm going to start coming in from a distance, and what you're going to notice is that some of the balls are going to start to move, and I wouldn't panic on this part, because as the flux starts to melt, some of the balls are going to move. That's why we wanted them as close to being in line as we possibly can, so as they don't start to merge with the other balls and cause us to have uneven sized balls. So coming from a distance, and you're going to start to see it dry up. And we're going to watch very closely. So we're going to watch every single ball closely. And eventually what you're going to notice is that every ball will start to be pretty much perfectly aligned with its respective pad as they start to melt. So keep a close eye on the balls, especially the ones in the corner, because that's the ones that tend to merge more, because that's where the flux tends to puddle up a little bit. I would say, judging by the fact that none of them have merged already, we're probably safe to come in a bit closer. Okay, so you can see that the balls have started to line up a lot better on that one side. So I don't see any balls really that I should be concerned about there. So I'm going to increase the airflow to 10%. I'm going to start moving air around. Okay, we can see that some of those balls are starting to cause a problem on the top there. So there's a couple of balls there which I need to adjust. So be very careful if you're doing this process, because it is very hot. But we do not want these two balls here to merge. It's not the end of the world if they do merge, but we just don't want them to. Of course, now the problem is the flux underneath the chip has melted, so it's causing an issue. So what I'm going to do then, because those balls appear to be fairly well stuck, I'm going to add some flux, and I'm going to pay close attention to that one particular area. And when the balls start to become a little bit more molten, I'm going to nudge them manually with my tweezers. So I'll add a little bit of flux. And you can see there that quite a few of them balls was not stuck on the top. Not a problem, I'll add them afterwards. So the way I'll deal with that is just to remove them. So any balls that are not stuck now, I'm just going to remove. So that should be fine. So let's come back in with the hot air then. Nope, those balls need to be replaced. Never mind, I can wick those away afterwards, it's not a big deal. I can wick them away and replace them. I'll increase the airflow now to 20%. I can fix the rest of those balls manually. Okay, increase the airflow another 5%. Okay, and this right here is a perfect example of why you don't want to solder balls too close together. So in a way I'm kind of glad that happened, because it means I can show you what happens when they are too close together. So if we take a closer look here, we can see that we've got two solder balls here which have merged. And the reason for this is because, like I said, the balls were too close together, and that's caused them to join together as one big ball. So what we need to do with this is we need to basically wick it away and get rid of pretty much an entire area, probably 6 or 8 balls. So we'll do it in as small of a group as possible. but we need to remove those merged balls, and we're going to hit other balls as we do it. So we're going to use a soldering iron with some wick like we did earlier on. However, the easiest thing to do is probably to take an entire section out. And now I want to clean the chip off. So the way I'm going to clean the chip off while the solder ball's on there is to use some isopropyl alcohol with a toothbrush. That's going to allow me to clean all of the flux from in the small little gaps. And then I'm going to need to basically do the process again, but just on a lot smaller field. And as you can see, we've got a few balls which we need to do. So not many, but we've got a few. But if we look at the other side, that other side is pretty much perfect. So we've got one solder ball which is still not cracked, but it's a little bit deformed. And the reason for that is because a little bit of flux didn't go on that one particular solder ball. So that's why we stress the importance of using flux, because otherwise you end up with out of shape balls and out of shape solder, cracks in the solder, things like that. So we need to get the other side exactly the same as this side, because otherwise these pads won't make a connection. So all we need to do to be able to do that is to basically do the same process again, but like I said, just on a much smaller scale. So as we can see here, we now have a perfectly reballed chip. And it took a little bit longer than it normally would, but it doesn't really matter. It's obviously this repair is not for any kind of monetary value or anything. It's just for the sake of trying to get it repaired. So I don't mind spending a bit longer on this. But all of those balls look nice and even, so we should be ready to get this installed. And the way I'm going to do that is, first of all, I'm going to add a layer of flux over the pads. So we want a nice thin layer to start with. We can add more flux later on. But let's add a thin layer of flux. And then we need to line up the chip so as it's in line with the solder balls on the actual board itself. So we're going to line up the chip with pin 1 in the correct location. The way to determine that is to look for an indicator on the board. In this case, there's a little dot just here in the bottom right hand corner, and we've got to line that up with the dot that's on the chip. So that's on the bottom right hand side of this chip. And then, because we can't actually see under the chip, there are some outlines here. So there's an outline here, an outline here, and then there's some outlines on the other side as well. But one way we can do it is to get it roughly in position. We'll feel it lock into place. So we'll feel the balls sit on top of the pad. Just like that. Whoops. That's a bit out of line there. So you can see that's barely moving as I'm nudging it with my fingers, unless I nudge it really hard. So that chip feels like it's in place to me. It's not really moving at all now. So what I want to do is I want to lift my finger off this chip, but the problem is my finger's now going to be stuck to it. So I'm going to grab a pair of tweezers, press down on the chip lightly, pull my finger away, and then pull the chip away. And that's going to allow me to release the chip without moving it out of place. So that's going to stay roughly in position now, but we can double check. It does look like it's a little bit slanted, but a tiny bit slanted isn't really going to hurt it too much. But we can adjust it if we feel like it's not quite in place, and I do feel like this isn't perfect. So I'm just going to give it a very gentle tap. There we go. And that looks like it's sitting nicely now in all 4 corners. And now I'm going to knock my airflow down to 10%. So a fairly low airflow, 450 degrees Celsius heat, and basically just solder this chip on using hot air. I'm going to circulate the heat as best I can. Of course, we don't have that much working distance between the top of the microscope and the board itself, so it's kind of difficult to get a good angle. But once I feel like the chip is going to be sort of tacked down, so sort of locked into place, I can add more flux, increase the airflow and solder it properly until I feel like it's soldered onto the board. Let's find out if this chip is soldered. Okay, that's locked into place. But I want to reflow it now so as the entire chip is soldered properly. So what I'll do now to make sure that it's soldered properly, I'm going to add some more flux and I'm going to reflow it properly. So I've moved the microscope out of the way so I can get a better angle. Doesn't matter how much flux I add now. And I'm just going to reflow it fully. And then I'm just going to give the chip a tap on the corner, make sure it springs back into place, a very light tap. And that's soldered. So now we need to let the board cool down for a couple of minutes, and then we can clean off the board, get it into a chassis, and hopefully this thing's going to work. Let's cross our fingers on this one. So let's clean off the board. So I'm just using isopropyl alcohol with a toothbrush. And there we go. So that chip is soldered. And as you can see, it is the same board. So all that's left to do now is find out a chassis, find a power supply, and see if this thing turns on. I've got myself a chassis and a power supply. I don't have a disk drive in this thing, but that's not really the important thing. The important thing is to see if this thing turns on and goes to a white light. So fingers crossed we haven't killed the RAM IC by reflowing it or by removing it, because that can happen. So what I need to do then is just clean off the old thermal paste that's on here, because like I said, this is a used chassis. Obviously because of the weight and things involved, all I received was the motherboard, so I need to put it into one of my own chassis for testing. And just clean off that with a cotton swab. There we go. Alright, so let's add some MX4 thermal paste. Nice half pea size in the centre of the chip will do absolutely perfectly. Let's drop that in there. Okay, let's get ourselves a heatsink clamp. And we need a few screws. Alright, so they're not the correct screws, but all I want to do is see if this works. I don't think I have any screws for this particular motherboard for the APU clamp, but all I want to do is just see this work. So let's cross our fingers and hope on this one, because I've been talking a big talk for a few weeks now. So let's try and get this working, shall we? Let's pop in a power supply there. And like I said, I'm not concerned about a disk drive, I'm not concerned about a hard drive, I just want to see it working. Even if it has no display or something similar to that, I just want to see it working. Then we can worry about getting it fully assembled into a working console. Let's hope for the best. Okay, that's overheating. Yeah, that's overheating because I don't have the correct clamp. I'm going to put some pressure on there. So what do you think? Is it going to go to a white light? So I'm just feeling around the RAM. None are getting incredibly hot. We don't have a white light yet. That's quite worrying. I may need to replace this RAM again. It could have killed it with all the heat. Nothing. Nothing. Okay. Well, that sucks. Just a little bit. All that work. I'll tell you what I'm going to try. If it doesn't work now, I'm going to try a reflow on the APU. It could have had some sort of an impact previously. That could be what was causing the RAM to be bad. And on top of that, it could have also had impact on the APU itself. The good thing is we can reflow it because I do have a BGA rework station. So reflowing the APU is an option for me. So I'm going to do that. I'm going to reflow the APU. Right, so the first thing I need to do to reflow the APU is just add some flux onto the edges of the chip like we did with the RAM. But first of all, I need to get rid of this thermal paste. So I will give you a little disclaimer here. That's that fact that this chip is far too big to ever attempt to reflow with a normal hot air station. And I would only attempt this job if you have a proper BGA rework machine. The machine that I use is an Atten IR Pro SC, and I've had a lot of success with reflows. And what a reflow does is those solder balls that we see underneath the chips, it essentially reflows all of those joints and basically rejoins any connections which might be a little bit weak or not making a connection because of warping, because of impact, or just because of the fact that it's lead-free solder, and the lead-free solder does have weaknesses. So they could have become deformed in some way, they could have become cracked in some way, We don't know, but it could well be an APU issue because I've replaced that RAM twice and it's not fixed the issue. There's no more overheating on that RAM. It's no longer getting hot, which means that RAM, in theory, should be functional. I'm not going to say it is functional, but in theory, it should be functional. And one other interesting thing as well is that I believe this is the PlayStation camera port. I'm not sure, but I believe this is the PlayStation camera port, and that is bent. So I've got a feeling that this has probably had some sort of an impact in the past. So that's interesting to note, the fact that it's bent. Alright, so let's add a bead of flux all the way around the edge of the chip. Right, so with the rework station set up, we're ready to drop the motherboard onto the top of the plate. And there's the board there. As you can see, it is still the same board. So what we're going to do with this then is we're going to reflow the APU. And what that means is, like I said, we're going to remelt all of the solder balls that are underneath the chip itself. And by doing that, hopefully we're going to reform all of those connections and hopefully fix this machine. Because the RAM is absolutely fine, and I believe Steve has already done several diagnostics on this, and the only thing he found wrong with it was the RAM. So that's pretty much all we can do apart from attempt an APU reflow. Now, I will stress that this is probably a last resort, and I wouldn't recommend doing this if you're obviously not experienced with this sort of thing. I do reflows and reballs pretty much every week. At least 2 to 3 times a week usually, so I'm really used to this. But you know, if you've never done this sort of thing before, then I wouldn't recommend it. But basically what we're going to be doing is we're going to gradually heat up the motherboard. So there's 2 plates on this. There's the top plate and the bottom plate. This is obviously the bottom plate, and then we've got a top plate on this thing here, and you'll notice that the top plate is in kind of a square shape, or rather it is a square shape, and it's a perfect size for the APU. And what we do is we heat up the bottom plate to 220 degrees, as you can see by the bottom plate just here. So 220 degrees the bottom plate is set to, and then once the bottom plate has got to 220, the top plate will kick in, and that will gradually increase to 100 degrees Celsius. When it gets to 100 degrees Celsius, it will hold there for about 30 seconds and allow the rest of the board to catch up. And then it will slowly increase until the top plate temperature gets to 220 degrees Celsius, and it'll stop along the way. So at 140 degrees it will stop, 160 it will stop again, 180 it will stop again, 200 it will stop again, 210, 220, and then it will hold on 230 until I hit stop. We don't need it to reach 230 degrees. Usually by the time it reaches 200, I can stop the process and the reflow is complete. But obviously, by allowing it to go to 230, I'll cover myself in any eventuality, because the temperature outside, the temperature inside, everything makes a difference. So fingers crossed we can get this thing reflowed. So I'm going to hit start, and you'll see that the bottom plate will start to kick in, and slowly increasing, 21 degrees, 22, 23, and so on and so forth. So I'm going to let this profile run, and I'll obviously fast forward through this because this takes around about 8 minutes. I'll resume the video when it gets close to being time to actually reflow the chip. So what we'll do is when it gets up to temperature and we feel like it's ready, we'll start nudging the chip with a pair of tweezers or something, and when we nudge the chip and the chip moves but springs back into place, then the reflow is complete. Surface tension will keep that chip in its correct position, and it will basically reform all of the solder balls. So we'll let this profile run, let the machine do its thing, and we'll carry on in a moment. And that is reflowed. So I've pressed stop on the heating process there and moved the top plate away from the APU to prevent it from heating up anymore, because even though I've stopped it, that top plate is still hot. So I want to allow this to cool down naturally now, and the reason for that is relatively simple. If I was to cool this down by any other means other than naturally, so for example if I was to hit the fan on the bottom plate, then there's a good chance that it can cause the solder balls underneath the APU as well as the rest of the board to go into what's called thermal shock. And what can happen there is it can damage traces, it can damage the balls underneath the APU, it can cause warping, it can cause all sorts of havoc on the motherboard. So we really don't want to be doing that kind of thing. So we're going to let it cool down naturally until the bottom plate reports around about 100 degrees Celsius. So right now you can see that the temperature is gradually decreasing, and when that bottom plate hits around about 120 to 100 degrees Celsius, then I can hit the bottom fan and assist in cooling. So what you saw there was me giving the chip a tap like we would tap any other chip, and the chip sprung back into place. So it was only a very light tap, but the chip sprung back into place, and what that means is that every solder ball was melted and that the chip was reflowed successfully. Now I will warn you as well that this process can of course kill the machine completely. It can cause popcorning on the chip, which is where the top layer will separate from the rest of the layers and cause damage to the APU. It can completely write off the APU full stop, or it can cause other damage to the internals of the motherboard as well, such as damage on another layer that's possibly weak or got some sort of a defect on it. So basically the reason I've reflowed this is because it's kind of a lost cause at the moment, and reflowing is pretty much the last option. If it don't work, then we haven't lost anything but time, and if it does work, then absolutely fantastic. I do have a fairly high success rate when it comes to reflowing, and I would say it's around about the 70% mark, where I'll get around about 7 out of 10 successful reflows. Around about 3 out of 10 are either unsuccessful, where they just don't change the situation, or where it turns to a complete no power or a 2-second blue light of death, where basically solder balls for some reason have merged underneath the APU. If it goes to a 2-second blue light of death, it's not the end of the world. We can reflow it again, sometimes that fixes it, and we can also reball it as well. So we can get a proper reballing stencil and reball the entire APU, which is about 1500 solder balls. So it's not one of those that you can do by hand like I did on the RAM chips, because there's a lot more solder balls. They're a lot closer together, and it's just a lot more awkward overall. I have done it once on a PS4 Pro, but never again. Never again will I reball an APU on a PS4, not by hand. So I'll let this cool down naturally, and then we'll get it off the rework machine and back onto the bench, and hopefully it fixes the problem. Alright, so this is about cool enough now where I can work on it safely, and what I need to do first is just give the board a good clean, because there's a lot of burnt flux around here now, and we obviously don't want to leave that kind of stuff. So all I do for that is just pour a load of isopropyl alcohol onto the board. Just give it a proper clean. And there goes that leftover thermal paste. I believe that was the thermal paste that was left on from before. I didn't clean it properly. Not a big deal, but never mind. And the one plus about this is that it's going to teach people the process of BGA rework. So whether or not I get this working, it's not a loss. Either way, the video will get posted, but it's not a complete loss if I don't get it working, because it does teach people the process of BGA rework, and it gets more people possibly interested in BGA rework. So hopefully it's at least helped a few people. I'm not optimistic about it, to be honest. It's looking a little bit bleaker every time I do something to it. But you never know. I've been surprised before. I've got quite a few videos on the channel where I've been absolutely shocked, because I thought something wasn't going to fix the issue, and it has. And I've just tried it out of pure desperation, if I'm honest. Not all repairs are scientific stuff. It's not always scientific stuff. Sometimes it's just trying your luck. And these are, it's more of an educated guess than anything, especially when when you're working on these every single day. You take educated guesses. You don't guess and just hope that you can fix it, but you take educated guesses and hope that fixes it. Not all repairs are simple and straightforward, but this is kind of a last hope. Okay, so that's clean enough for testing, I think. Not completely clean, but it's clean enough for testing. What we do need though is some more thermal paste, so let's get some more MX4. I'm pretty sure Steve will tell me if that's the perfect amount of thermal paste. Okay. So my bench is an absolute state, but again, part of the process. Let's clean off the rest of the console. Let's get rid of this thermal paste as well, because otherwise it won't be the perfect amount. Alright, that will do. Let's hit and hope and pray that it works. So we've got some flux and stuff on the back. I'm not bothered about that. And I'll tell you what I will do. I think if this goes to a 2-second blue light of death, I'll reboard it. I'll do a proper reball. Why not? Just for the funds. So right now we're coming up to 3.5 hours of working on this. So I would say another hour and a half won't hurt on a reball, should I need to. Alright, definitely, I think this chassis is damaged, to be honest. I'm not sure, but I think this chassis is damaged. Because the screws just don't bite. There we go. Moment of truth. Well, we don't have a 2-second blue light of death. So it's either going to work or it's not. And a reball won't help because it's not gone to a 2-second blue light of death. Unless there's trace damage. But a reball won't help. That's going to go to a white light, ladies and gents. That fan just stopped and started. That's going to go to a white light. Come on. Show me. Yes! Let's go. Oh, yes. Let's go. Oh, wow. I am so happy. That was a clutching at straws moment and it worked. Oh, wow. Yes. And I know for a fact there's going to be people in the comment section saying, how did I know it was going to go to a white light? Wow. That is unbelievable. This console has come all the way from America. It's gone through so much along the way. And it's working. Do we have a display? Let me switch over to my capture card. Yes, we do. Yes, we do. That is fantastic. I've got to sit here and hold this APU in place because I don't have the correct screws. But that is fantastic. Oh, that is awesome. I need a hard drive. Wow, I'm so happy. Right, I need my test solid state drive. Okay, my bench is such a mess, I don't know where the test solid state drive is. Let's forget the solid state drive. Let's just use this. I honestly don't know where my SSDs have gone. I've got a test SSD for the PS4 and one for the Xbox, and I don't know where they've gone. I can't believe that's happened. I can't believe that worked. Well, I can, in a way, I can believe it, but that's absolutely brilliant. Such a fantastic end. Okay, so while I'm sorting this out, while I'm getting this SSD out of here, you're probably wondering how I knew that was going to go to a white light. And I say this all the time while I'm live streaming. And the fact is, I know it was going to go to a white light because the fan stopped spinning and then started again. There's certain things that we need to look out for when we're working with the blue light of death system, and I do these all the time. I work on these every week, like I said. There's certain things we need to look out for when we're working with the blue light of death system, and on the original PS4, the 1000 series, the power supply relay will click just before it goes to a white light. On the 1200 series and onwards, the fan will stop spinning and it will go to a white light just after it restarts the fan. It's one of them things I've picked up along the way. I know this is a bit ghetto, but please just just allow this. Just allow this moment. It's a little bit ghetto, but just allow it. Okay, let's start it back up. Let's start it back up. This is fantastic. Let's get that white light again, shall we? There we go. There we go. Okay, we are now in safe mode. So what I need to do now to complete this is I need the system software. Steve said he's had this console for a long time and I'm not sure what software is going to be on it, but I'm going to download whatever operating system is on it. If that's version 1, then it's version 1 that I'll download. This is absolutely brilliant. Okay. And we need version 5.55. Excellent. Okay. So I'm going to pop in the USB. And then I'm going to press OK. Hopefully I don't need to find a disk drive out. But the Renesas IC is on the motherboard on these particular models, so I shouldn't need the disk drive. Although I do sometimes. Sometimes it doesn't let you do it without the disk drive. But we'll give it a whirl. And yep, that's accepted it, so we can press OK and that will install the software, and yeah, we'll take it from there. We'll give it a test. The one thing I can't test because I don't have one to hand is a disk drive, but I can test it to make sure it loads to the dashboard and things, and show you this console actually working, which is a couple of words that I didn't think I was going to say at one point, but it's certainly nice to see this console turned on and with a white light, that is for sure. And this is the moment of truth, about to hit 100%. Just rebooting now. Updating system storage. Okay, let's run through the setup and let's give this one final test. I'm not going to be able to test Wi-Fi. I don't have an antenna. And I'm not going to be able to test the disk drive, but let's make sure that it views in 1080p. And that's pretty much it. So very doubtful it's going to pick up a Wi-Fi network. Oh, hang on. Okay, so there's a very important message here. So the password to my Wi-Fi has a subliminal message in it, and you should really pay attention to that if you're new to the channel, because it's a very, very important message. That is genuinely the password, by the way. The memes, we love it. Okay, let's skip that. Absolutely shocked that that's even picked up Wi-Fi, but the router is fairly close. And Where's my time zone? It's here somewhere. There we are. 22nd of the 1st, 2021. It's actually picked up the... I think that's the correct date, isn't it? Yeah, it really is. Wow. That's quite surprising. Isn't that a beautiful sight, ladies and gents? Let's test the video output. That's on automatic, so that's going to be working in 1080p, so that's awesome. That's absolutely awesome. And there we go. Oh, go away. There we go. Excellent. Absolutely awesome. All working. Okay, I'm having a couple of controller issues here because I don't have a Wi-Fi card, a Wi-Fi antenna plugged in. But that, ladies and gents, is all she wrote. It's been an absolute joyride. I've enjoyed every single moment of it, and I'm just super happy that I've managed to get this console working. And just to show you that it is still the same console, because I know for a fact there's going to be a couple of people in the comments that say that it's been faked somehow, because there always is. But that's one of them things that we have to deal with on YouTube. But as you can see there, it is still exactly the same motherboard. But just to summarise on this then, so this was sent by Steve from TronicsFix in America, and I want to say a big thank you to Steve for giving me this opportunity. The console originally came with one of the RAM ICs removed, so that was this thing just here, and I had to reball the RAM. I did end up putting a second RAM IC on there just because I didn't know if the first one had gone on okay. That obviously didn't fix the issue, so I ended up reflowing the APU using my Atten IR Pro BGA reworkstation. Like I said, it's not something that everyone can do, I understand that, and not everyone has a BGA reworkstation. In fact, probably 95% of technicians won't have one. But that's just something that I happen to have, which is why it was such a blast to be able to work on this machine, because I knew that I can pretty much do anything I want with this thing. But again, I want to say a massive thank you to Steve from TronicsFix. If you don't know who Steve is, there'll be a link in the video description. If you are new to the channel and you like what you see, be sure to hit the subscribe button down below and turn on the bell notifications so that you don't miss any future uploads. If you do want to support the channel, I do also have channel memberships where you can support me and what I do here for as little as £1.99 per month. I know it's preaching a little bit, but it does help the channel out a lot. But that's going to be it for this. It's been an absolute blast, honestly, genuinely from the bottom of my heart. I want to thank Steve from TronicsFix and everyone else. A big thank you to everyone. But that's going to be it for now. Thank you very much for watching. Until next time, see you later. Bye for now.